How you going, guys? Curtis from Cutting Edge Engineering. So today's job, we have a D10 equalizer bar out of a D10R bulldozer. We need to do some line boring on it. There's quite a lot of damage done to the left-hand side of the bar. Haven't greased it. The bearing has failed. It's started to break apart, and after they start to break, it's all over. It generally destroys the ends beyond help in the field. They've got to come back to a workshop and be line bored or repaired. The other side of the bar also needs doing as well. Where an equalizer bar is actually located on the machine, it's mounted up underneath the engine toward the back of the motor. There is a pin that goes through the equalizer bar that then connects that to the chassis of the machine. The two ends then go out to each track frame, so your left and your right. And as one track frame comes up, the bar equalizes that and then lowers the other side, so they can walk over rough terrain, rocks, stumps, trees, whatever they want to do. So essentially this is the only suspension a bulldozer has. There's a lot of stresses put throughout this particular part of the machine. It is very, very common for these bars to wear out. They sort of get overlooked during services. They are a greased component. Not many people actually take the time to go and grease them. The centers don't generally give much trouble because they're not a steel on steel bush and pin arrangement. They're actually a fiber bushing. So that's just basically a woven fiber bearing. They don't require greasing or lubrication of any nature. It doesn't do as much moving, even though the entire weight of the machine is on this particular part when it is doing heavy ripping or heavy pushing. So it is quite common to see the equalizer bars break through the middle. That just sort of explains how much load is on them. But this one's in pretty good shape. We don't have to do anything to the center. We just have to repair the outsides of the bar. The ends of the equalizer bar, they actually get a lot of movement. So they use what's called a spherical bearing. So that one doesn't fit anymore. When the spherical bearings are in the machine and these are attached onto the bar, there is quite a lot of movement there, considering the track frame can lift quite high on both sides. So you couldn't run a standard style bushing or a centered bushing out here. They must be a ball bush or a spherical bearing. It is basically a ball with a hole through it for the grease and the pin. So no, that bearing isn't broken. They split the bearings, they don't cut them. They split them and break them. That way the two halves meet perfectly back together again. So you can actually see on the bearing there is a chisel mark where it has been split on both sides, and they fit perfectly together. If you did try to fit them the wrong way, nothing fits. We do need to set the line bore up on this to start the boring and welding process, but before I do that, I have to go through and drill out all the grease holes. So there are a grease hole in and two grease holes out, so you don't over pressurize the joint and blow the seals out. I'll get all these holes drilled out, we'll get the line borer set up on the job, and we're going to start boring out material. That is not actually a grease nipple, that is actually a relief nipple. So if you over pressurize it, it pushes the little plunger up, which is not there anymore, and allows the grease to escape. So the two outer ones are supposed to be the relief valves, and the inner one will be the grease nipple to supply grease to the bearing. If we have a look on the inside, there are no grease holes there anymore. They've been smeared over, or they might be full of dirt, grease, debris, stuff like that. So I'm just going to drill them out now to get them cleaned out before I start setting up the line borer. You've got to be kidding me. Right, so cannot drill through that hole. There is something in there along the lines of a drill or maybe a tap or a piece of bearing material that's gotten up into that hole, but there's no way grease was getting in there. So someone cut a corner here, made a mistake and just put a grease nipple in and forgot about it. I've tried that many different drills that were designed for drilling the hardest of hard. So our R2 drill bits can drill through pretty well anything, including broken taps. but I just can't even get a starting point on this one, so I don't know what it is. I'm going to assume it's a bit of bearing. It could be a tap or it could be a drill. It'll be interesting to see what's in there, but if I can't drill it, there's no way I can line bore it without destroying tools. So it's best I tackle this part of the problem first, then I'll line bore it without being concerned about breaking inserts or tools. What I'm going to do is come in from the underneath side. I'm going to preheat that area red hot, and I'm going to destroy a drill and try and punch all the way through it. We'll try this one. Why do I hold the torch against a job when I'm turning on my oxygen? That is because with LPG it's not as flammable as acetylene, and it doesn't sit on the end of the torch. It actually sits off the torch by about an inch. If I turn the oxygen on, it'll just blow that flame out. So light it, sit on something, keeps the fire at the tip, won't blow it out. You've got to be kidding me. Right, so all efforts have failed so far. So I'm going to take a burr, die grinder, and I'm going to try and expose whatever they've put in there and try and retrieve it. Someone cut a severe corner there and the customer paid for it. I'm going to get it out. The crack in there, you can see that something's been welded in there. It started to crack. There it is. So they've basically welded over a bit of bearing that was trapped up in the grease hole. It is quite common for them to break down to a point where they will fit through there. And what they have done is, rather than try and get it out before they actually welded it, they just welded over the top of it. I think that's it. Right, so that's that end sorted out. This end is a little bit different. So this also has a grease nipple right in the middle. It has the two reliefs drilled that go down through the snap ring grooves, and there's also side ports drilled in. Then there are threads tapped into each of those and grub screws put in there to blank them off. The idea of that is if you overcharge the center one, it will come back up through the grease ports coming through the snap rings and then go sideways up to where your grease fitting goes on, where you're pumping the grease into to let you know there's grease going all the way through. So this one could be as equally, if not more exciting as that side. Okay, so there's no grub screws. There's no grub screws in there. So that went really smoothly because no one put the grub screws back in there to allow the grease back through the ports to tell you it was being overpressurized. But the holes that go in through the top here don't make it down into the actual bearing cavity itself. So they're all pointless. I don't know why people cut corners, but they do. They're put there for a reason. When they're set up correctly, they work. Now what I'm going to do, I'm going to drill these holes out to a closer size to what they need to be. During assembly, I'm going to run a tap back down these holes so I can then put grub screws back in there to make this function as if it was standard. People cut corners and get lazy and don't do this because it's too hard basket for them, or they can't drill straight. Or I don't know why, but the amount of these that come through my workshop that are half-assed is just beyond the joke. So we're going to set this one up correctly, back to standard, so the customer doesn't have any more dramas with it. Now that we've got the line borer set up on the job, we're going to go through and punch out all that material. We are going to take it below the base of the snap ring groove. Trying to weld inside a 4mm groove with a rotational welder never ever ends well. Material from the welding will never get deep enough inside that groove, so we're going to take all that material out, including the seal faces, because they're pretty torn up from where someone's attacked them with a cold chisel, and the customer has requested that everything go back to brand new. So we're going to get on to boring it out. Alright guys, so we've completed the boring. We're going to do 2 layers of weld in there to build up what I've removed. It's always best to remove a little bit extra material just to make sure there's no surprises under it. We did find a little bit of porosity in the second layer that we were boring out, so get rid of all that, put in some fresh material, and we know we've got a good foundation for our new bushings and our new seals. So the first layer of material we're going to put back in here with the bore welder is going to be the full width of the eye. The second layer, we're going to start at 10 mil inside and stop at 10 mil early. It doesn't need to be there. We have seals that are going to go in those areas. Come on. Come back inside. Come on. Outside of the line. go. Righto guys, so we've completed the 2 layers of welding we needed to do on the insides of the eyes. They're all cooled down, ready for machining. I've just had the customer deliver the parts over to me, and I've discovered they have bought the upgraded seal kit, which is found in the latest series of the D10s. The difference between the 2 seals is they're about 10 mil bigger in diameter, and they're a couple of mil thicker, which is no big deal. It's actually good they're doing the upgrade, because being they're a larger diameter seal, they're less likely to tear the centers or the outers out of the seal itself and allow debris into the equalizer bar. As for the welding I've already done on the bar, I do need to remove a little bit more material in order to fit the new upgrade. Righto guys, so we're about to cut the snap ring grooves in the equalizer bar eye. What I'm using is a shop-made snap ring cutter. So what this is a piece of 40mm bar that I have made to suit the line bore with the keyway in it. I've then adapted a boring and facing head to the bar, and as it spins in the machine, I hold that collar there and that advances the tool out very, very slowly. There's just a 2mm parting blade that I've used as the snap ring cutter itself, and then if I need it to be wider, I simply just advance the machine forward using the feed motor. This is quite effective. It has its limitations. We are working on a new idea, but for the time being, this works pretty well. We've drilled out all those holes to allow the grease back up if they overcharge it. What I need to do now, I'm going to run a tap down these threads just to clean them up a little bit. Something I would never do or recommend doing, be run a good tap down a rusty hole, because it's just going to destroy the tap. So if you've got an old tap that's done a handful of jobs that's still semi-cutting, just run it down there, take it easy on it, because the material gets so hard when it starts to rust. It just takes the edge off your tap. So use a buggered one, say reckon a good one. Just rips your taps apart.
Get it. Get it.
Put the camera on me. This one is fun. You get it. You get it.
Get it.
You get it. Okay.
Ooh.
Okay. Righto guys, so it's day 2 of our equalizer bar. I had an urgent job come in that I had to get through, and I also needed to do a bit of a cleanup. It was pretty messy in here. Now that the bar has been reclaimed, all the ends have been machined, all the grease holes have been drilled, we're going to start fitting the new parts. We're not going to put any aftermarket parts in the equalizer bar, being how much of a nightmare these are to remove out of a machine. They're a very awkward part. They're extremely heavy. It is about a day's job to replace this on a job site. So spend a little bit of extra money, put genuine parts in, and they just go so much further. Just another thing to remember with spherical bearings or a ball bush that have a 2-part cup, when putting them in, you don't want to put them in like that with the join at the top and the bottom. Being that that's where the most load will be on this bearing while the machine is in operation, what will happen is the inner ball will actually force its way into the cone and it'll spread it out and everything starts to break up. You want to put them out to the side so the load's top and bottom to give the bearing the best chance of survival. Not only that, the grease holes in the top and the bottom of these There is none through the side, so if you do put them in like that, there's a long way for the grease to travel and a very good chance that the grease will never actually make it in there. Over time, they will build up with debris and dirt, and the bush will run dry, it'll start to break down, and then it'll fail. Righto guys, so something else I do that is a little bit different to others I know that do the same work as me. I don't put the standard grub screws back in because they're only steel and they tend to rust into the hole and make it a very, very difficult time for the next guy to try and get them out. So I actually use a stainless steel grub screw. That way they don't lock in the hole so hard. You just put an Allen key back down, pull them back out, and they don't lock up. So do myself or the next guy a favour. Put stainless steel ones in, they can then be removed. Good little trick. Unfortunately, the customer didn't supply us the little relief valves that go on either side of the main greasing point. So because we didn't get them, we're not going to put grease nipples back in there because that'll completely seal that off. And if they then go and pump that full of grease, there's a good chance they'll pop those seals out. So we're just going to put in some little plastic plugs. So if they do over-grease it, it'll just blow these plugs out until someone decides to order in the correct little relief valves and install them. Right, so now that the ends have been assembled, we've got all the seals, bearings, grease nipples, everything put in them. We need to fit the center bush and the seals. Being that I don't want to try and flip this over in the press to fit the opposite seal, I'm going to hammer one in and then we'll take it over the press, push the bush in, and then we'll push the seal in behind it. Why am I using 680 Loctite retaining compound to hold seals into the ends of the bar? I've been doing these bars for this customer for 5 years now. I've never had one of my bars come back where the seals have popped out. I'm just going to continue to use the 680. So it's a high strength retaining compound and it just does the job. Arch nemesis. Righto guys, so job's done now. We've got everything line board, all the new parts fitted. A few little surprises like that piece of bearing that someone had welded over the top of. But all in all, it went pretty well considering equalizer bars can hold far more surprises for you. Parts are in, job's done. We're going to get it back to our customer. Is there a booger?
No.
The hat on straight?
Yep.
Sure?
Sure.
Check it?
No. I think you made it not straight just then.
Oh.
Yep.
Right. What an equalizer bar actually does is... So it's mounted here in the center of the... Where the equalizer bar is mounted on the machine, it's mounted up underneath the machine, up the... Oh, fuck my fucking dog. Righto guys, so we've got all the bar... Fuck, I've already lost it. Righto guys, we've completed all the machine... Oh fuck, hang on a minute. Having a moment here. Now that we've got the bar back to a, you know, rebuilt state when it... We're gonna go ahead and start fitting the new components. We're gonna go ahead... Now that we've got the bar, hang on. Right, hang on. Just put the camera back up. Don't fuck around. We'll get a good one sooner or later. Fucking hell, got all day. And then you can just put a wrench. Now I'm talking American, which doesn't. It only. Fuck. And it's no big deal, but fuck, I lost that. Right. Fuck off, bird. So the customer's just dropped off. Fuck up. So. Fuck off. How dare you?
Yep, go with your hand movements. Do the thing. Sure, that arm looks really strange. Like,
Down here?
yeah.
Yeah.
Oh, Dad, sneeze on your arm. Up. You're just
Grease
moving
nipple.
so. Yeah, do the next one. Whatever.
That's it. There's only one in there. Where's the other fucking two? Where's the fucking hole?
It's like not even a little pinprick of a hole yet.
I'm not even moving with the drill.
Oh my god.
You've got to be fucking kidding. You've got to be kidding me.
Jesus.
Fuck. God fucking God. What a fucking joke. God. Fuck, I'm over this shit. So I'm going to assume this one has been repaired by someone who half-assed it, like a piece of shit. So, fuck you. You fuckheads. So we call this stuff character building.
Very good. Carry on.
Moving forward.
All that for that.
That is a piece of bearing material.
That was easy.
Fantastic. Never enough fucking storage space in these. So fucking hot.
Put a glove on. God.
Silly. Fuck.
I'm wondering if you can get it past the camera while the camera's still there.
Damn it.
Let's go. Something fell on the ground and something's gone up the end of it.
What? How?
I nailed it. Righto guys, so we've got the job done now. Oh,
What was wrong with that?
I don't know.
This way. Come here. Wow. Okay. Is that fun? All right, come on.